Hi, welcome back. In this video walkthrough, I will show you how to execute code and complete quest number 3. So let's get started. You have to first initialize AOS by typing in the AOS command, which I've already done. I am getting a prompt by the name of points coin because I was trying to load the token blueprint and I did not change the token name. But if you also happen to get the same error, don't worry about it. In this video walkthrough, I've combined the instructions for Quest 2 as well because it's important to understand how the game has been constructed and how a default bot operates. And in this, I will show you the list of possibilities and list of changes which you can make to create your own bot. I will show you my own code and I will show you how to execute all the codes and complete the quest. And in the end, I will also show you how to get the CRED for this quest. For this, you will have to paste the code in the Discord server in a particular channel and wait for the admins to review the code. So let's start. Let's start by checking what's the details of quest number 2 by executing this command. So quest number 2 is bots and games. Leveraging insights from a previous chapter, this section will guide you through the realm of automation with bots in AOS and construction of games. You will learn to create autonomous agents, using them to navigate and interact with game environments effectively. Game ID has been mentioned, that's the process ID of game, and the register and request token commands have also been mentioned. We also have been presented with a link which has the tutorial for bots and games, and the user can get CRED rewards by playing a full game in above arena with the bot, and hence after that you will be rewarded. I would also suggest you to look at quest number 3 because that is also quite related to quest number 2. So I'm going to run this command to see the details for quest number 3. Build a bot. Build a novel autonomous bot for the AO effect arena. AO effect is an arena where autonomous agents living inside the computer battle in order to win testnet cred from one another. Each bot stakes a token to take part in a round, and those that eliminate other bots get to claim their tokens. To qualify for this quest, build a custom bot and launch a new bot for the arena. Game ID has been mentioned and prerequisites are quest number 2. If you have not completed quest 2, please go back. And how do I get cred? In Discord, post your bot source code in the build a bot review thread. So here, one thing to note is we have to complete quest number 2 in order to proceed to quest number 3. And game ID, which has been mentioned here, please check for it in the Discord channel because there are high chances that this is an old process ID and there would be a new one because the AO team has been updating the game process quite a lot. Let's go through the basics of the game and bot again so that you are able to understand the reasoning behind the code which has been written in the default file, and then you can change it to prepare your own bot. Open the cookbook and navigate to the page of bots and games. You have been powering through tutorials like a champ. Now let's take a refreshing break and dive into something exciting. How about a game that adds a dash of fun to your learning journey? AO Effect. Arena style. That's the game. So what's the game? AO Effect is a game where you can compete with your friends and other players globally in real time. right from your terminal. We have set up a global game process for this adventure. The rules are simple. Each player starts on a 40 by 40 grid with health at 100 and energy at 0. Your energy replenishes over time to a maximum of 100. Navigate the grid, find other players, and use your energy to attack when they are within the range. The battle continues only until only one player remains or allotted time expires. Check out the guides on mechanics of arena and expanding the arena for deeper understanding of the game. So in more quests, we are required to build a game by ourselves. So hence these two mechanics of arena and expanding the arena tutorials or guides would also be helpful. I would suggest let's go ahead with understanding of at least mechanics of the arena. So AO effect, which is the game, it's the arena game, and let's understand how it is built. So this guide provides a comprehensive view of fundamental mechanics essential for designing and managing arena-style games in AOS. In arena games, participants engage in rounds, strategically vying to eliminate each other until a sole victor emerges. The framework presented here lays the groundwork for crafting a wide range of games, all sharing the same core functionalities. So understand, the core functionalities would remain the same. So it's important to understand this tutorial very deeply. Explore the intricacies of game development and unleash your creativity within this versatile arena. What are the core functionalities? I think there are 7 in number. Yeah. So let's dive into the core functionalities that power arena style games. I have noted it down on the text document and I'll share that with you. See, mechanics of the game. Game progression modes. Arena games are structured into rounds that operate in a loop while following the progression modes. Not started, waiting, playing, and then someone wins or timeout, and then waiting again. The loop timeout if there are not enough players to start a game after the waiting state. Rounds offer a definite time frame for players to engage, intensifying the excitement of gameplay. So not started to waiting to playing, and then if someone wins or times out, and then waiting again. It comes back to waiting and not started. Token stakes. Players must deposit a specified quantity of tokens defined by payment quantity to participate in the game. These tokens add a tangible stake element to the game. So, payment quantity is the amount which we need to deposit to start to participate in the game. Bonus rewards. Beyond the thrill of victory, players are enticed by the prospect of extra rewards. The builder has the flexibility to offer bonus tokens, defined by bonus quantity, to be distributed per round. Any bets placed by players are also added to these bonuses. These bonuses serve as an additional incentive, enhancing the competitive spirit of gameplay. So it's the bonus quantity which would be distributed per round. And if any player bets more, that is also added to these bonuses. Player management. Players waiting to join the next game are tracked in the waiting table, and active players and their game states are stored in the players table. Eliminated players are promptly removed from players table and placed in the waiting table for the next game. That makes sense. So there are two types of table, waiting table and player table. Waiting table has the list of all participants waiting to play the game, and players have the players who are playing it. Moving on, round winner award reward. When a player eliminates another, they earn not only bragging rights but also the eliminated players deposit tokens as a reward. Additionally, winners of each round share a portion of the bonus tokens as well as their original stake, further motivating players to strive for victory. So it's their stake, but the stake plus the stake of player they eliminated plus the bonus tokens. So it's deposit plus bonus plus original. We can actually change it. It's the deposit, their original deposit plus bonus plus eliminated player. Eliminated player's deposit. What's the listener mode? For those who prefer to watch the action unfold, the listen mode offers an opportunity to stay informed without active participation. Processes can register as listeners, granting them access to all announcements from the game. While they do not engage as players, listeners can continue to observe the game's progress until they explicitly request removal. So it's the listen mode. We can also try that. Let me just make a note of it. So instead of register, we can use listen to listen. Listener. Action is listen. Game state management. To maintain the flow and fairness of arena games, an automated system oversees game state transitions. These transitions encompass waiting, playing, and ending phases. Okay. Time durations for each phase, such as wait time and game time, ensure that rounds adhere to definite time frames, preventing games from lasting indefinitely. Wait time, that's for the waiting time, and game time is for the player's table. I think you are able to make a connection here. If not, tag me, I'll answer your query. Okay, you can refer to the code for the arena in the drop down below. So that's the blueprint. We are just going through it. We are just going through the blueprint so that you are aware of what is going behind the scenes. And for one of the quests, we have to create our own game. So this would be helpful. Arena game blueprint. For those interested in using this Arena's framework, we have made this code easily accessible through a blueprint. Simply run the following code in your terminal. So that's .load -blueprint arena. Can you recollect the code which we have already used, similar to this one? Yeah, that's .load -blueprint space chat. So understanding the mechanics of the arena can not only help you improve your autonomous agent created in the previous section, but also empowers you to harness core functionalities for crafting your unique games. In the upcoming section, Building a Game, we will dive deep into the art of utilizing these mechanics to construct captivating and one-of-a-kind games within this framework. Get ready to embark on a journey into the dynamic realm of game development. Okay, that's what would a bot do? Bot would help us in reading the announcements in a terminal directly. Instead of using the inbox square bracket hashtag inbox closed square bracket command, the bot would help us directly revealing what the message is. So that would help us in orchestrating our moves and attacking the player so that we can win the game. So I hope announcements are clear. Announcements are messages which are dropped directly into the inbox and we have to check it regularly. So what about having a bot? I think that's a good idea. So let's understand this part. Welcome back to your coding journey. It's time to use the skills you have acquired from previous tutorial to enhance your gaming experience. During the game, you have likely noticed announcements appearing in your terminal. These announcements are the game's way of communicating important events to the players. However, these messages can sometimes seem cryptic, or you might find yourself checking your inbox frequently for further details. Wouldn't it be convenient to access this information directly from your terminal? Yeah, well, there's a way to do that. So this line also mean that the bot would help us accessing the information directly from the terminal without us checking the information again and again. So by using handlers, you can create autonomous agents to retrieve this information for you, marking the progression from simple bots to entities capable of interpreting and acting on game events directly. What are handlers? Handler library provides a flexible way to manage and execute a series of handlers based on patterns. Each handler consists of pattern function, a handle function, and a name. And these are so many handlers. Great. The code is well written. The cookbook is also well written. Moving on, setting up the development environment. Start by creating a new file named bot.lua in your preferred directory. So that preferred directory is the directory where you have that .aos.json file. Okay, this means the same. Ideally, this file should be placed in the same directory where your player process runs to ease the loading of the code. Else you will need to use a relative path to access the file. See, I have created another empty bot.lua file and I'm going to write it in front of you step by step. So let's dive into the logic. Each handler in AOS requires three pieces of information. See, a pattern, a handle function, and a name. So name, a unique name for the handler, pattern, a pattern for handler to identify, triggering its operation, and handle, the operations to perform when the desired pattern is found. Name is there. Once that handler identifies a pattern, this is the operation which the handler executes. Simple. Easy peasy, lemon squeezy. Here's how you can write a handler for printing announcement details. This is essentially what we wanted to achieve, isn't it? Just copy the command, everything, and copy and paste it here. Press Ctrl S, move ahead. In this case, the name of the handler is print announcement. Print announcements. It uses a special inbuilt utility, has matching tags. That's the pattern detector. To check the incoming messages has been tagged as an announcement. As an announcement, this checks, and if true, the handler prints the event and data which represent the title and description of the announcement. Event and data which represents title and description. Once a message is handled, it will be discarded from your inbox. So inbox won't be populated. Loading and testing. Let's bring this to life in a game. Navigate to your AOS player's terminal and enter a game session. So we'll do that later. The process to entering a game session. So after that, we'll have to activate the handler. Activate the handler by loading your bot.lua file with .load bot.lua. See, our commands are very simple and there's a lot of similarity. Because it's a customized file, we are using .load function. Otherwise, we could have used .blueprint-load. No, actually, it was .load. Okay, it was something like that. I will just check. It was .load-blueprint and chat. Chat is a predefined file. Similarly, we have .load bot.lua, but it's a customized file which we have created. You can also change the name. Probably you can do it bot your name.lua, but that would also work. You will now see game announcements appear directly in your terminal, offering real-time insights without the need to sift through your inbox. Congratulations! You have just taken a first step in building a bot on iOS. But let's keep working on adding more features to it. Fetching game state. Now that you are seeing game announcements directly in your terminal, you have a better grasp of the game's dynamics. However, these insights are limited to specific actions occurring within the game. Wouldn't it be more useful to have an on-demand access to comprehensive game data like the positions, health, and energy? So these are the only three things which are related to each player. Position, that's something by default. Health, that's 100 by default, and energy, that's 0. This information could significantly improve your strategic planning, helping your assets assess threats, opportunities, and timings more effectively. If you thought of adding another handler to the bot created in the previous guide, you are absolutely right. So we are going to add more information. So go back to the file and update your existing handler as follows. Handler.add handle announcements has matching tag. This is the same one. And we have send and print. So we have renamed it to handle announcements to reflect its broader role. Nothing. Print announcements have been changed to handle announcements. Addition of an extra operation to request the game for updated state. The game is designed to respond to get game state action tag, which we already know. See, I'm not written it, but I'll just write it here. This is also a good command. You can use it to check the state of the game. When you get a print of the announcement, you can check the latest message in your inbox as follows. Which we already know. So moving ahead, the data field of this message contains the latest state of the game, which includes game mode, whether the game is in waiting or playing state, that we know, and there are corresponding timers to it. One is related to the waiting table and one is related to the playing state. The time remaining for the game to start or end. So for waiting also there's a time limit, and for playing also there's a time limit. Players, a table containing every player's stats like position, health, and energy. Okay, every player has three unique elements associated to it, or three dimensions. One is position, second is health, and the third is energy. But this can take up a step further so that you cannot just read but also use information from the latest state of other automations. Let's define a new variant that stores the latest state as follows. Latest game state is latest game state or nil. Okay, we are storing the game state. The syntax preserves existing values of the variable when you load successive iterations of the file in your terminal instead of overwriting it. Okay, if there is no pre-existing value, then nil value is assigned to the variable. So it says syntax preserves the existing value of variable when you load successful iterations. So when we load the file again and again, the existing values are preserved because this is how the command would run. Then implement another handler as follows. Handler to update the game state and upon receiving game state information. That's the name. That's the, what do you call? There are three parts to a handler. Are you able to recollect that? Yeah, again, each handler consists of a pattern function, handle name, handle function, and a name. So that's the name. That's the name. Then we have the pattern function. That's the pattern, and that's the handle function. Handler has a name. That's the pattern, and that's the handle. So copying it, we have to first copy this as well. And then copy this. See, latest game state, which we have already defined above. And first, that's the printing announcement thing. And then this code is to update the game state upon receiving the game state information. That's the name. That's the pattern. Pattern is the game state, and that's the handle. Okay, moving ahead. We have repeated so many times so that you are able to understand it well. I hope it's clear for you. And you don't have any queries. If you have any queries, don't hesitate. Ping us, ping me, and I'll try to resolve it. The response from the game process from the previous handler has an action tag with game state that helps us trigger the second handler. Once triggered, the handle function loads the inbuilt JSON package that parses the data into JSON and stores in the latest game function. So I'll try to explain. The response from game process from the previous handler as an action tag with value game state. Okay, see, game state is there. And then this helps us trigger the second handler, which is this one. And once triggered, the handle function loads in the build on JSON file and parses the data into JSON and stores in the latest game state. With this is triggered. This code gets the data and stores in this variable. Moving ahead. This handler additionally sends the message to your process indicating when the state has been updated. The significance of this feature will be explained in the following section. You can refer to the latest code in the dropdown. So, see, instead of defining the variable in between, which is not a good practice, we will define it at the top. That's the first handler, that's the second handler. I'm just going to replace the code. Moving ahead. Loading and testing. As usual, we know it already. To test this feature, we have to load the file as follows .load bot.lua. Then check the latest state variable to see if it has updated correctly by simply passing its name as follows, latest game state. I'm noting it down because we have to execute it after we register. So these are the actions to be taken when we participate in the game. In the game. And we have to also load the file load bot.lua. Do you remember the command .load -blueprint space chat? Yeah, that's for loading the predefined functions. So with real-time access to the latest state of the game, your bot is equipped to make informed decision, decide your next action. Next, let's try automating actions with the help of this data. Okay, strategic decisions. With the latest game state at your disposal, your bot can evolve into an autonomous agent. Autonomous agent which takes actions by itself. This transition marks an upgrade in functionality, enabling not just reactions to the game states, but strategic actions that consider context, energy, and proximity to make decisions. So basically, we have to consider the context, we have to understand the energy of the player and proximity in order to attack. That's the decision which we have to make. So writing the code. Return to your bot.lua file and add the following functions. So first we have to determine the proximity with this function in range x1 y1 x2 y2 range. If this is less than equal to range or this is less than equal to range, then we have to return the value. Strategically decides on the next move based on the proximity and energy. So based on these values, our bot would decide if player energy is 5 and target is in range, then attack or otherwise not attack, because player is in the range but inefficient energy. So player has to be in the range, energy has to be more than 5 to attack. That's the main point which we have to understand. The decide next action function is now a testament to our agent's ability to think and act on comprehensive understanding of the environment. Yes, it analyzes the latest game state to either attack if you have sufficient energy and an opponent is in range, or move otherwise. Now all you need is a handler to make sure this function runs on its own. So I'm going to append this in my bot.lua file. Moving ahead, I'm going to add this value as well. Decide next action, name of the function, has matching tag, that's the pattern, and that's the handle. See, pattern, handle, name. We start with name, we check the pattern, and then we have our commands in the handle function. This handler triggers upon receiving a message that the latest game state has been fetched and updated. An action is taken only when the game is in playing mode. You can refer to the latest code in the drop-down below. Let us compare our code with this. We have this for sure. Then do we have handle announcement? Handle announcement is there. Update game state is also there. These are the values which we need. These are not the handlers per se, but these are some variables and functions which have to be described above all the code. And then we have the decide next action handler. So all the handlers are in between. First you declare the variables, then you have the functions, and then you have the handlers. This is how the code has to be written. So we can just simply replace this code. All good so far. It's easy peasy lemon squeezy. Loading and testing. Once again, we know we have to load the file in the AOS player terminal with this command. So observe your process output to see the decisions your autonomous agent makes in real time, leveraging the current game state for strategic advantage. But what if another player attacks you and runs away while you are deciding the next move? In the next section, you will learn to automatically counter as soon as you have been attacked. So far, we have understood how to handle announcements, how to make an autonomous agent which gets the current game state and then strategically decide if we need to attack or not, basis if our player is within the range and has energy more than 5. Following our last guide, our creation has promoted from a simple bot to a sophisticated autonomous agent. Now let's further enhance its capabilities by adding a counter-attack feature, allowing it to instantly retaliate against the opponent's attack, potentially catching them off guard before they can retreat to safety. So add the following handler to the file and UR set. So these are the handler. Do you remember where we need to add the handlers? Yes, at the bottom. So I'm just going to copy it and paste it in my code at the bottom. So when your player is under attack, you receive a message with the action hit. Action is hit. Let me go through it. Name of the handler is return attack. That's the pattern checker, and that's the handler. That's the handle basically. So when your player is under attack, you receive a message with action hit. So that's the hit message. Then this setup ensures your agent can make a swift counter attack given it has sufficient energy. See, if player energy with latest game state, if player energy is undefined, then print unable to read the energy. If player energy is 0, of course it has insufficient energy. If attack fair, player has no energy, else returning attack. Basically, if it is more than 0 energy, then a player would attack, and tick is the action which we'll get. So we can refer to the latest code. These are the variables, these are the functions, and then player energy, we have already seen this. These are the handlers. Handler announcements is one, update game state is another, decide next action is another. Then we have return attack, that's the last one. So in all, that's the bot.lua file which we were looking for. Thank you, AOS team, for sharing this code with us. Our bot creation has been so simple. AO team is working quite hard to make sure that everyone understands the code and everyone is comfortable in executing all the commands. Thank you, team. Loading and testing. To activate and test the counter attack feature, load the bot file in your AOS player terminal. That's the .load bot.lua. Watch your terminal for autonomous agents reactions, now with the added ability to retaliate instantly. This feature showcases the agent's evolving strategic depth and autonomy. In the upcoming section, we'll consolidate all the knowledge we have gathered so far and add some features for optimization. Okay, bringing it together. This final guide wraps up our series where you have built an autonomous agent piece by piece. Now let's refine your agent with some optimization that's fine-tune its operation. Here's a quick overview of the key improvements made so far. Sequential command execution. The introduction of InAction flag ensures that your agent actions are sequential. Next action occurs only when the previous is successfully executed. This critical addition prevents your agent from acting on outdated game states, enhancing its responsiveness and accuracy. The full implementation can be found in the final code. So this is a variable which we need to add at the top. Moving ahead, dynamic state updates and decisions. The agent now employs an automatic tick logic, allowing for dynamic updates and decisions. This logic enables the agent to self-trigger state updates and make subsequent decisions either upon receiving a tick message or upon completing an action promoting autonomous operation. Tick message is the message which is announced at a retaliation. So this is I think we can add it in between. These are all the handlers. So let me check. Yeah, this is an handler as well. See, that's the get game state on tick handler. Has matching tag, that's the pattern, and that's the handle function. Automated fee transfer. To further streamline its operation and ensure uninterrupted participation in game, the autonomous agent now autonomously handles the transfer of confirmation of fees. Okay, auto P is the handler. We'll just add it at the bottom. In addition to these features, we have also added a logging function. for debugging purposes and colored prints for better comprehension of game events. These enhancements collectively make our autonomous agents more efficient and adaptable in game environment. Check out the complete file in the drop-down below with all the new additions highlighted accordingly. See, these are the two variables. Logs have been added, colors have been added, functions are there. Then we have the handler, print announcements, get game state on tick. Auto pay is also there, update game state is also there, decide next action is also there. Then we have return attack and we have the tick action. I must congratulate you for understanding the code along with this discussion. We are just going to replace the code and our bot.lua file is ready for action. So you are now equipped with the knowledge to craft intelligent autonomous agents. It's time to apply these insights into the game world. Understand the game's intricacies and leverage your agent's capabilities to dominate the arena. But there is more to come. In future sections, we'll dive deeper into the game arena, offering advanced strategies to elevate your agent's performance. Ready to take on the challenge? Let's see what you can create. Like I prepared a text file for Quest 2, I prepared a text file for Quest 3 as well. This is for quick reference. And I've noted down my learnings by reading the cookbook. I mentioned the mechanics of the game processing modes which are not started, to waiting, to playing, to waiting again, the token stakes, payment quantity, these were the variables used. And I mentioned the directions as well. These were the commands we executed in Quest 2. So enhancing on the learnings, these are the final steps. A big shout out to Johnny Ringo, Tom Ruckus, and AO team for debugging and helping me out. I've expanded on my notes of the last quest, and this is the part for quest 3 which we need to execute. So first I would like to show you my bot. This is the source code for my bot.lua file. You can open and copy the code from GitHub. So for ANSI color codes, these few colors were given as part of the default bot.lua file, and I've added a few more colors. I've shared the list for you. You can use these colors and customize your bot. I've removed the code for the log section. My reasoning is I wanted my code to be lean, so I removed this. In the next part, where we have to check if 2 points are within the range, I did not change this code, but I added this part. So my strategy to prepare the bot was that to decide the next action based on player proximity, energy, health, and gate map analysis should be used. I prioritized the targets based on health, that is weaker first, distance, that is closer first, and strategic positions. And I also analyzed the map for choke points or advantageous positions. So this is the new code. So this code loops through all players in latest game state.players, excluding the player itself, and to find the closest target with lowest health within the specified range. This best target is intended to be the focus of attacking. So local best target equals to nil stores the ID of the best target player considering health and distance. Then to find the closest and the weakest target within the attack range, I executed these commands. So I'll just read out line by line and explain what these lines mean. So for target state in pairs latest game state.players do. So this loop iterates over each entry in this table in this array, which is a table or array where each key target is a player identifier. And the corresponding value, which is the state, contains the data about player state, example, position, and health. Do you remember we executed the command latest game state and we got an array? So latest game state is that array which stores the latest game state, and by this command we iterate over each entry and the corresponding value contains that data. Moving to the next line. On the previous line, I would like to mention that it is not a complex line. It's not a complex code. It's a for loop. We just want to check each player's health and state, and this is why we have written this command. In line 2, the target not equal to ao.id and in range, the condition checks two things. See, this is the command and this is the explanation. The target is not the current player. Okay, the condition checks two things. If the target is not the current player and the function in range returns true, indicating that target is within a certain range of the current player. See, if this and this. So if this is not true, then this is, if it is not the current player, it returns true as the output, the return out variable. So the target is not the current player or the agent. This ensures that the player does not consider themselves as the target. That is quite important. The function, this in range player x, player y, state x, state y, returns true, indicating that the target player is within a certain range of the current player, and this specifies of how in range calculates this are not provided, but it likely checks if the distance between two players is less than or equal to the specified range. So basically it checks if the two players are in the range of 1, which is quite important. Then the next line is target in range equal to true. So if these conditions are met, this line set a flag variable target equals to true, indicating that at least one target is within the specified range has been found. So I think up till now, I'll just summarize. In this array, we have to go through all the pairs, all the players, and then if for values other than our own ao.id, we have to compare, and if the player is in the range of 1, then it returns true, and the target in range, this variable is set to true. Moving to the next line. If not, best target or state health is less than the best target health, or then. So see this code. If not this or this and then this is less than this, then what happens? So this condition checks three things. If not best target, that is, if not best target has been identified yet, the current state becomes the best target. So if one player is within the range of 1, the player becomes the best target if we don't have the best target already identified. Next is state health is less than the best target health. So if state's health is less than the health of the best target, the current state becomes the new best target. So basically, if health is less than the best target's health of a particular player, and if it is in the range, then that player becomes the new best target. So this implies a preference for targets with the lower health. So this is the new strategy which I employed. Now the next step is state health equal to best target health and in range less than 1 less than in range 1. So if current state has the same health as the best target but it is closer, then it becomes the new best target. This suggests that if health values are equal, the closer target is preferred. And last line is best target equal to state. So if any of the conditions for the choosing best targets are met, the state of the current state target in the iteration becomes the new best target. So, summarizing what I have done in this particular set of code is, first, in the latest game state, I check for all the players, I check their health, and I also checked their position. So, if the position was close to my player, in the range of 1, then I allocated it to the best target. And if already a best target was identified earlier, for this particular new value, I compared the health. And if the health of any of these players was lower, that was assigned as the new best target. Basically, best target is a variable which I am using to identify the player which I need to attack based on two things. One is proximity and the other thing is health. So first step, check the proximity. If it is in the range, then check the health, and the one having the lowest health would be identified as the best target. Hopefully it's clear. If you have any queries, do DM me or contact me on social media. I will try to answer your queries. So I did not change the other commands, other handlers. I hope you already know this from the bot creation of Quest 2. Next is the print game announcement, trigger game statistics. There was one more change which I did. I used only 4 directions. Do you remember how many directions are there? So just for a quick reference, 1, 2, 3, 4, 5, 6, 7, 8. So I'm using just the top 4. This is also one thing which you can do. You can either take the top 4 or the bottom 4, or randomly select 2 or 3 directions from this. So that can be also one of the strategies. So this is the entire code. This is the same code which I discussed with you without the comment. So I saved this file as bot.lua and executed it and completed the quest. So what you can do for your own creation of bot. I've identified a few strategies which you can use. So first of all, it's important to understand that purpose of Quest 3 is to build a bot that uses a different strategy than the default bot which is provided in the cookbook. So what I've seen in the server is few people are just copying the code directly from the default bot.lua file and using it as the code for their bot, and they're claiming the rewards for Quest 3, which is not the right thing to do. These are few things which you can do for your own bot. One is movement strategy. You can prioritize attacking. The default code prioritizes moving randomly if no player is in the range, so you could prioritize movement towards the recently seen opponents. You can store the last known value of nearby players and try to move closer to them on each tick. These are the directions which I have mentioned. This is the code which you can use. It can be used to move the player away from other players. Uh, I did not use this as my strategy, but you can use it. Local player equal to this latest game state players dot ao.id, and then you can uh, use these commands. If x is greater than 0 and y is greater than 0, then you can turn to down left or up left, down right, up right, down or up. So you can try to move player from other players and gain energy. Next is attack strategy. Attack selection. In the default code, the code attacks with all the available energy. You can consider implementing a more strategic approach based on opponent's health and your remaining energy. For example, use a lower attack power if it's enough to finish the opponent. For that, you will have to again read the latest game state, store that value, compare, and then execute the code. Next is information management. You can cache frequently accessed information from latest game state like your own health and energy to avoid redundant lookups. You can optimize logging. I completely deleted the code from my bot.lua file. You can consider disabling or reducing the logging during the gameplay. That would ensure that your bot is faster. Next is exploring libraries. Depending on the available Lua libraries in the game framework, you might be able to utilize functions for pathfinding or distance calculations, potentially improving the movement efficiency. So you can explore Lua libraries. And then the best strategy is to uh, adapt basis the specific game mechanics and opponent behavior, experiment with different approaches and gather data on effectiveness to refine your bot's code. So now let me just execute the code and show you how I completed this quest. The code which you have prepared in the bot.lua file, you have to save it in the same directory where .aos.json file is there, and then you have to initialize the game by the following commands. See, first we are initializing the game ID, passing it to the variable name as game. In the next step, we have to load bot.lua file. In the next step, you have to send this message, which is send target equal to game, action equal to register. The next step, you have to request for tokens. See, I've got the message registered. And because the bot is already working, because we loaded bot.lua file in the beginning, I'm getting these messages as well. And I also played the game once, so hence these messages are coming up for me on my screen. You might also get it in some time. I think the best strategy would be loading bot.lua file before initializing game equals to the process ID. Now we have to transfer the quantity. Message added to the outbox. Credit notice. Credit notice is because we requested for tokens. And now because we have transferred some tokens to the game ID, we are going to get the debit notice message as well. Message has been already added to the outbox. See, debit notice has come. And what's the next step? We just have to do nothing. Basically, we have to wake up the bot again and again and executing. See, payment received is the message I got after the debit notice. And you just wait and see, the bot would perform all the actions and your quest would be completed. Next is claiming CRED rewards for quest 3. You have to first save your bot.lua code in GitHub. You will get this kind of a link, and then you have to post the link in the Discord group. This is the link of my message in the group. This is where you need to post your code for the review. In Quest, you will find a thread called as build a bot review. This is where you need to post your code for review. In the Quest channel, you will find build a bot reviews thread. In that, you have to post the code to be reviewed by the team. This is what I shared with the team a few days back, and I got the rewards in 24 to 48 hours. I have a request to make. After you have shared the code, please give team time of 24 to 48 hours because the code has to be reviewed manually and the rewards would be processed after the review. In this, we also have AOS UI build thread and build a game thread, which are the subsequent quests which we'll be completing, and I'll be sharing a video with you. And after 24 to 48 hours, you check the balance by executing this command. So I executed the command for checking the balance and my CRED balance has been updated. With this, we have reached to the end of this video walkthrough. Thanks for watching. I'll complete the other quest and will share the video soon. Have a nice day.